Alright, so today we're going to look at parallel lines and proportional parts, and we're going to look at the same thing but with triangles. So, we need to determine whether the triangles are similar and justify our answer. So first off here, we'll review from the last video. We know that angle C, or at point C there, we have two angles that are vertical angles, so they're congruent. So we know that angle ACB is congruent to angle ECD. Now at this point we have these parallel lines that are marked that can tell us also that angle D and angle B are congruent. Also angle A and angle E, but we only need two to prove that they are similar. So angle D congruent to angle B. So we have angle-angle similarity. So that means that for our similarity statement, that triangle ACB is similar to triangle ECD. Second one, we need to make sure they're similar prior to setting up our proportion, because it doesn't tell us that they are. But once again, we have vertical angles in here, and we have two right angles, one on each triangle. So that means we do have similar triangles. So we can set up a proportion, and we're going to call the side we're looking for, the distance across the river, x. So we can do a couple different ways. We'll do the 24 over 30. Those are the sides that are not going up and down, equal to x over 28. Those are the sides that are going up and down. We just got to keep them in the right order. So x and 24 need to be in the same position on the fraction, and they are. So now we just need to cross multiply. 30 times x is 30x. 24 times 28. So 20 times 20 is 400. 4 times 20, or actually 8 times 20, sorry, is 160. Now 4 times 20 is 80, and 4 times 8 is 32. So we add all these up, and we get 672. Now we need to divide by 30. And 30 goes into 60 two times. 67 minus 60 is 7. So then we bring down the 2. So we have 72. 30 goes into 72 two times. So we get 60. 72 minus 30, or 72 minus 60 is 12. So we have to bring a 0 down. We have a decimal. And 120 divided by 30 is 4. An even 4 at that. So this is 22.4 meters. And that's our answer. So the only vocab we have left for this unit is the midsegment of a triangle. So first, the triangle proportionality theorem. If a line is parallel to one side of a triangle and intersects the other two sides, then it divides the sides into segments of proportional lengths. So let's use this now. Here we have in triangle RST, side or segment RT is parallel to segment VU. SV is 3, VR is 8, and UT is 12. We need to find SU. So since we know they are parallel, that means that they cut them into proportional segments. So all we have to do is keep the same side in the same fraction, same ratio. So 12 over x, or x over 12, equal to 3 over 8, because they're on the same side and in the same order. If we go the other way, we'll have some problems. So we need to cross multiply. 8 times x is 8x, and 3 times 12 is 36. We divide by 8. And 36 divided by 8 is not an even number, or not a whole number. 8 goes into 36 4 times to get us 32. And so then we have 4 more to go, and that 4 is half of 8. So 4.5 is what x is. Next theorem basically just takes our previous theorem and flips it backwards. So now we don't know that the lines are parallel, but we do know that the sides are proportional, which tells us that then we can say that the lines are parallel. So if a line intersects two sides of a triangle and separates the sides into proportional segments, proportional corresponding segments, then the line is parallel to the third side of a triangle. So our next problem, we actually need to determine if these are parallel lines. So in order for GH to be parallel to FE, our sides need to be proportional. So let's label everything in our picture. We know DH is 18, and we know HE is 36, and we know that DG is 1/2 of GF. We don't know anything else about GF, so we'll just leave it as GF. So let's set up our proportion. 1/2 of GF over GF is equal to 18 over 36. This has to be true in order to make these things be parallel. So first off, we can simplify. We have GF on top and bottom on the left, so we can cancel those out. And then we're left with a 1/2 equal to 18 over 36. And now we just need to decide if this is a true statement or not, because we just have numbers left, no more variables. And so it really is 18 half of 36. And yes, this is a true statement. So because that is true, that means that we can say that GH is indeed parallel to FE. Here's our next theorem, the triangle midsegment theorem. So the midsegment is just another parallel line like we had before. However, something special, or a few things that are special, happen with the midsegment. First off, the endpoints of the midsegment are the midpoints of the sides that it intersects. So in this case, J is the midpoint for FH, and K is the midpoint for HG. Also, KJ or JK, whatever you want to call it, our midsegment is half of the length of the base that it's not touching. So FG is double JK. So we're going to use that a few times, and we have 3 problems here that all use the same image. So in the figure, DE and EF are midsegments of triangle ABC. We first need to find what AB is. So since we know that ED, or DE, whatever you want to call it, is a midsegment, and AB is the side that DE is not touching, that means that AB is equal to 2 times DE. We also are given what DE is. It says it in the picture. It's 5. So DE is 5. We just plug that back in. So AB is 2 times 5. And 2 times 5 is 10. There are no units here, except for the angles. So part B here, same picture, different question. Now we just need to find FE. And again, FE or EF, whichever one you want to call it. They just name it both ways here for some reason. EF is a midsegment. So that means that we know that BC is equal to 2 times FE. We know what BC is. It's the whole length 18. It's on the right. So that means that 18 is equal to 2 times FE, which is what we're trying to find. Now we just need to divide by 2. 18 divided by 2 is 9, so 9 is equal to FE. So here's our next one. Same picture, different question. Now we need to find the measure of angle AFE. So, once again, we remember that mid-segments are parallel to the sides that they are not touching. So that means that DE is parallel to AB. So we have two parallel lines. And FE is our transversal. We are looking for this angle here, and the alternate interior to it is 87. So, since AB is parallel to DE, and the measure of angle FED is equal to 87, then the measure of angle AFE is equal to 87, because they are alternate interior angles. So next part here, proportional parts of parallel lines. If three or more parallel lines intersect two transversals, then they cut the transversals proportionally. So now we're saying that AB over BC is proportional to EF over FG. So let's use this. Here we actually are conveniently given a triangle. So if the street here that's not named, but it has X and 16 on it, would have not intersected, then we still could have used our proportion, since we know that Larch, Maple, and Nuthatch are all parallel to each other. So that means we can set up our proportion X over 16, or 16 over X, equal to 13 over 26. So we just need to cross multiply. 13 times x, 13x, and 16 times 26. So 10 times 20 is 200. 6 times 20 is 120. 6 times 10, 60. And 6 times 6 is 36. So we just need to add these up. 6, we got 11, carry the 1, 416. Now we just need to divide by 13. 13 goes into 41 3 times to get 39. So then there would be 2 left over. 26 is what we have now. 13 goes into 26 2 times evenly, and we don't have any units, so it's just 32. Congruent parts of parallel lines. So now, same thing is applying here, but now A, B, and BC are congruent. So not only are they proportional to EF over FG, they're also congruent to each other. And since they are congruent, EF and FG are also congruent. No matter how many lines after that, once we know one is splitting into two equal pieces, then anything that goes through those 3 lines is going to do the same thing, or more if there's more than that. So we need to find x and y. Since we are given that the sides with the x's are congruent with our little marks, that means we know that the other sides we are not given are also congruent to each other. So 3x minus 7 is equal to x plus 5. Subtract x from both sides. 3x minus 1x is 2x minus 7 equal to 5. We add 7 to both sides. Two x is equal to 12. We divide by 2 on both sides. X is equal to 6. So now we do the same thing for y. 9y minus 2 is equal to 6y plus 4. We're going to subtract 6y from both sides. 3y minus 2 is equal to 4. We're going to add 2 to both sides. 4 plus 2 is 6. We divide by 3. 6 divided by 3 is 2. So y is 2, x is 6. Alright, so now if two triangles are similar, the lengths of corresponding altitudes are proportional to the lengths of corresponding sides. Now, the rest of these definitions are all saying the exact same thing. The only thing that changes is the word altitudes. So from altitudes it goes to angle bisectors, and then angle bisectors goes to medians. But regardless, whatever the special segment is, they are all going to be proportional to the lengths of the corresponding sides. So here we are given medians, since they do intersect the midpoint of JL and QS respectively. So we need to set up our proportion. We have some options here. We can do x over 12, or we can do x over 8. Or not x over 8, x over 5. And we could do x over 12, or x over 12 and 5 over 8. Or we could do x over 5 and 12 over 8. Either way, it doesn't matter, because what we're going to end up doing is multiplying the 5 times 12 and the 8 times x. So x over 5 is equal to 12 over 8. We're going to cross multiply again. 8 times x is 8x. And 12 times 5 is 60. And we divide by 5. So x is equal to 60. 8 does not go into that evenly. It does go in 7 times. We're left with 4. And 4 is half of 8, so 7.5. Okay, so estimating some distances. Sanjay's arm is about 9 times longer than the distance between his eyes. He sights a statue across the park that is 10 feet wide. If the statue appears to move 4 widths when he switches eyes, estimate the distance from Sanjay's thumb to the statue. So, since we don't have units for 9 times the distance between his eyes, we're going to say the distance between his eyes is just 1. And of course 9 is the distance from his eyes to his thumb. We don't know the distance from his thumb to DF, or to the statue, but we do know that the statue moves 4 widths. So that means that our equation here, our inequality, was out to be 9 over x equal to, so 9 is the altitude here, and x is the altitude, so we're going to go from small base to large base. So that's going to be 1 over 40. That's 10 times the width, right? So 4 widths is 4 times 10, which is 40. So now we're going to cross multiply. And 1 times x is just x. 4 times 40, or 9, sorry, times 40. 9 times 4 is 36. We add the 0, it's 360. Our units feet. So, here's our last theorem, the triangle angle bisector theorem. An angle bisector in a triangle separates the opposite side into two segments that are proportional to the lengths of the other two sides. So, what that means is we just need to set up a proportion, and we've got to make sure that we keep like things in the right places. Okay, so here we have an angle bisector. It's showing that by the arcs that are in the angles, and so now we just need to set up our proportion. The first proportion you want to set up, first ratio, is x over 6. We want to keep the two that are being split apart from each other together. So x over 6. And then for the other ratio, you're going to do the side that goes with whatever is on the top. So x is on the top. The side that goes with x is the 15. And 6 is on the bottom, so the side that goes with 6 is 9. So that goes on the bottom as well. So now we cross multiply, and 9 times x is 9x, and 6 times 15 is 90. Then we divide by 9, and x is equal to 10. And we do not have a unit here, so just 10. And that is it for these notes. That is it for Unit 4. Stay tuned for Unit 5.